Today we talk about blockchain. So what is a blockchain? Blockchain is a very special ledger. Basically, it is a distributed database of records or public ledger of all transactions. Each transaction is verified by consensus of a majority of participants, and it is immutable. Being immutable here meaning once information is entered, it cannot be erased. A blockchain is an order-byte linked list of blocks of transactions. So it starts with a genesis block or block 0, which is the first ever block in a blockchain. The genesis block has the child, and the child has its own child, etc. A blockchain can be stored as a flat file or a simple database. Each block is identifiable by a hash, and the hash basically is an algorithm that maps data of arbitrary size to a bit strings of a fixed size, and this is one-way mapping. The hash is an algorithm, usually SHA-256. Information in a block is hashed and stored in its child in the previous block hash field, and the child block is linked back to the parent block via this field. A hashing function basically is a function that maps data of arbitrary size to data of fixed size. An example is the function h of x, which is x mod n, is a hash function for integer keys that maps integers to a few values, such as breakfast, lunch, brunch, and dinner. In this hash table, each key is corresponding to an element. Knowing the key, we can get the corresponding element. Hashing functions are commonly used for hashing passwords and storing password in the database. So later on, when users come in and enter username and password, the password is then hashed again via the hashing function and then compared to the hashed password already in the database. And if they are the same, then the users are allowed to log in the system. Bitcoin uses SHA-256, and if you'd like to try how SHA-256 works, then you can try this piece of code, which takes the string Yukon as the password. The hash can later on be returned using hashdigest and can be printed. And this is what you can see as the hash of the string Yukon. In the blockchain, each block contains the hash of its parent in a header. The header of this block in its turn is hashed again, and the hash is stored in its child. And this process repeats again and again downstream. When the parent block is modified, the hash changes. This leads to the changes of the previous block hash pointer of the child. The change of the pointer then causes the change of the hash of the child as well, which leads to the change in the pointer of the grandchild, and the change of the hash of the grandchild, and so on. So once a block has many generations succeeding it, it cannot be changed without forcing recomputation of all the subsequent blocks. The long chain of blocks in the blockchain falsify the history immutable, and this is a key feature of blockchain technology security. A block is a container that is made up of the header and the transactions, and a block can be identified by referencing the block hash or the block height. The block header consists of three sets of block metadata. The first is the previous block hash, which is a pointer pointing to the parent block. The second is related to the mining computation, including the difficulty, timestamp, and nonce. And the last is a Merkle tree root, which is a data structure used to summarize the transactions in the block. This figure illustrates the hashing of the block header and storing the hash in the child. This previous block hash points to the parent block, so when the block header in the parent changes, this pointer changes as well. Talking about nodes in a blockchain network, there are full nodes that store the complete blockchain locally. The full nodes are able to verify all the transactions since the beginning of the blockchain. The partial nodes store part of the blockchain infrastructure, but not necessary to be a miner. They do not check or download the whole blockchain. A miner in the blockchain creates blocks in the blockchain, which other nodes keep. Basically, the miner works on transactions to come up with the hash to store the information. Nodes share blocks and transactions across the blockchain network. In addition to block hash, block height is another method to identify a block in the blockchain using the position. The Genesis block, which is the first ever block in the blockchain, is at the block height 0. And since then, each subsequent block in the blockchain is higher by 1 in height. And it is possible that 2 or more blocks compete for the same position in the blockchain to have the same block height. A blockchain starts with the Genesis block. For any blockchain, we can start at any block and follow the chain backwards. Then eventually we can arrive at the Genesis block. Every node can identify the Genesis block's hash and structure, time of creation, and transactions, so has a root to build the blockchain on. Each node in the blockchain network maintains a copy of the blockchain locally in the node, starting from the Genesis block. The local copy of the blockchain gets updates as new blocks are discovered and subsequently built on. At a node, when new blocks are discovered, the node validates the blocks and link them to the existing blockchain. What does the node do? It first checks for the previous block hash in the incoming block header. This hash actually is the hash of the parent block, and the hash is known to the node previously, so now it knows the new block is a child of the last block on the chain, and it adds the new block to the end of the chain, make it longer with the new height of the incoming block now validated. Each block in the blockchain contains a summary of all the transactions in the block using a Merkle tree, and this tree is also known as binary hash tree. The tree contains cryptographic hashes and is used for summarizing and verifying the integrity of data. In a Merkle tree, nodes are paired and hashed until there's only one hash, and this is called the Merkle root. The Merkle trees in Bitcoin use SHA-256 applied twice, also called double SHA-256 for hashing. With the number of data elements hashed and summarized in a Merkle tree, you can check to see if a particular element is included in the tree, and this is to verify if a transaction is indeed included in a block. This figure illustrates a Merkle tree example. Here we have 4 transactions: TXA, TXB, TXC, and TXD, hashed and stored in each leaf node as HA, HB, HC, and HD. The value in each node is the double hash of each transaction. For example, HA is to SHA-256 applied twice on transaction A. The hashes in the child nodes are then concatenated and hashed in the parent node, and this process continues upward until there is only one node at the top, and this one node is the root of the Merkle tree. Its hash is stored in a block header, and it summarizes all the data in the 4 transactions. The interesting thing is the Merkle tree is able to summarize any number of transactions in the block to just 32 bytes. Now we talked about title insurance. Title insurance is a form of insurance. This type of insurance insures against the financial loss from defect in home title. Title insurance coverage usually depends on whether you have a lender's or an owner's policy. In general, you need to buy a lender's policy if you take out a loan from a mortgage lender. Title insurance covers the lender up to the amount of the loan in the event that any problems arise with the home's title after financing. Blockchain can solve the cost for title insurance, of which a one-time premium is about $1,000, which covers the upfront work and ongoing legal and loss coverage. Premiums vary from about a few $100s up to about $2,000 or $3,000. Why do you need title insurance? Think of the case when you buy a home and then later on realize that the previous owner hadn't paid the property taxes for several years. And there are many other cases that you'd like to protect yourself from risk, and that is where title insurance comes in. Title insurance is required by lenders to make sure this is a legitimate deal with someone who has a full right to sell the property to you. How can blockchain technologies solve this problem? With a blockchain, a secure ledger can be used to make sure the person that you are buying the house from actually owns the house. Another application is in money transferring. Many domestic wire transfer may take 24 hours, but international wire transfers may take longer, as many as 5 days. Money transferring from a US bank account to a PayPal account also takes 3 to 5 days. Blockchain technology can solve this problem easily because funds between accounts can be transferred instantly. There are other problems that blockchain can help, such as car theft. A secure ledger can be used to check and verify that you own the car, or prescription fraud, which is very widespread. Prescription pads are stolen from physicians' offices and written for fictitious patients. Some patients enter the physician's prescription to obtain additional drugs. And there's just a few problems, and also there are many other problems. Blockchain technology can be used to solve this problem. First, patients receive tokens from the blockchain and then later on present the token to pharmacist. At that time, blockchain can be used to check and make sure the patient owns the token. There are more other applications of blockchain, such as real-time financial statements, property title transfer, medical record management, and election voting, in which blockchain is checked to see if a voter has a token to spend.